everyone, so this is our second lecture. It's physics of P4, first topic, circular motion. Um, this topic has applications in many other topics. So what is circular motion? Motion of an object about a fixed point at a constant distance. So for example, this, and this is the center, then the radius is constant throughout. So this is a circular motion. What is an angular displacement? Angle swept by an object in a circular motion. For example, if I say that a body moved from A to B and now is here, so it moved some angle on the center. So this angle is called the angular displacement, and in this case it's clear that it's pi, which is 180 degrees, right? So the symbol for angular displacement is theta, and the SI units are radians. It means that we write it as pi. Formula is, I have used the relationship. So as long as the radius is constant, more the angle, more the linear displacement cover. For example, if an object covers till C, right? So the angle will increase as well as the displacement covered in the circumference. The distance from A to C is obviously greater than A to B, and then the angle will be greater too. So linear displacement is directly proportional to angular displacement. Linear displacement is represented by S and angular displacement by theta. So whenever we have to remove this proportionality sign, we insert a constant, in this case, which is R. So the formula comes out as S is equal to R theta. Let's look at the common question which we see in exam papers. So how the angular displacement is 2 pi in one complete rotation. So as we have been learning from previous classes, that the formula for the circumference is 2 pi r, and we just figure out the relationship between angular and linear displacement, which is this: x is equal to r theta. We'll equate both of these, and then r will be cut out, and then it leaves us with theta is equal to 2 pi, which is the angular displacement in one complete rotation. 2 pi is also 360 degrees, which is the angular displacement in a circle, and we have been studying that 360 degrees is a complete rotation in a circle and is equal to 2 pi. Moving on to angular velocity. Angular velocity is angular displacement per unit time. Unit time is seconds, as we deal in SI units. So its symbol is this small w. We often call it omega. So SI units would be radian per second, as it is defined as angular displacement per unit time. So for one complete rotation, let's see, we have just learned that for one complete rotation, the angular displacement is 2 pi, and for one complete rotation, the time taken is defined as time period, which is represented by a capital T. So here it is, and then putting it in this formula, we'll get omega is equal to 2 pi over t, or we'll just write it as 2 pi f by replacing t with f. Again, there can be many formulas for calculating one quantity. We'll use the one for which the values are given in the question. For example, sometimes we'll be given with time period, sometimes we'll be given with frequency. So depending upon the question, we'll choose the appropriate formula. Now let's look at another common question we come across while solving papers. It's like this. So any data can be given with can be given, including these values. So here this is the angular displacement, this is the linear displacement, and then this is the radius. So radius is marked as x naught. Since the radius of circle remains same, so when the object comes to B, the linear displacement will be x naught. So x naught is the maximum displacement this object can cover. So maximum displacement is called amplitude, right? And amplitude is represented here by x naught. So x naught is the amplitude, which is equal to radius. Let's see how to calculate x. we have to calculate x if x naught, that is amplitude, is given. So reminding the trigonometric ratios, which are so, ka, doa. The most appropriate one is sine here. So we'll use sine. Sine is equal to opposite over hypotenuse. So opposite is x and hypotenuse is x naught. So sine theta is equal to x over x naught. X naught will be multiplied here. Then x is equal to x naught sine theta. Again, there are two formulas. We just substituted theta with omega t. As we have learned that omega is equal to theta by t, we multiply t here, so theta becomes omega t. So we just substituted here. Again, we'll use the formula according to the question. It all depends on the information given in the question. Now here is another example. It asks us to find x at a given time, 12 seconds, with time period t and amplitude of 10 centimeter. So just write the formula first. As the value of theta is not given, we'll substitute it by omega t. Again, we don't know omega, we'll substitute again. It will be 2 pi over t into t. So x naught is what, 10, but again, look, it's centimeter. Convert it into meters since we work in SI units. Sine into 2 pi over 5 into 12. Let's see. So x is 1.14 meters. Moving on to relationship between linear and angular velocities. So what is velocity? Velocity is basically displacement over time. So I have written here the formulas for displacement and divided the both sides with time. So we get a formula for velocity, which is right here. So velocity is equal to r omega. We can substitute omega in any way according to the question. Let's see acceleration. Since the body is moving in a circular motion, so there has to be a driving force which drives the body in a circular motion. That driving force is called a centripetal force, a force that compels the object to move in a circular path. So whenever there is a driving force, there is an acceleration, and acceleration is a vector quantity, so it has direction. So let's see where the acceleration is directed in this case. Observe that a body moves from A to B. At A, its velocity is u, and at B, its velocity is v. Even if the magnitude of the velocity is same, it's still changing direction, which means that there is acceleration. So since velocity is a vector, so we drew the vectors here. In order to complete it in a head-to-tail rule, we need to change the direction for u, which I have done right here. So I changed the direction of u, and the resultant vector became v minus u. So if we draw it here, then v minus u is always directed towards center. If v minus u is directed towards center, then A is definitely directed towards center because acceleration is equal to v minus u over t. Hence the point proven that acceleration and centripetal force always acts towards the center. Now let's look at the formula for acceleration. There is a long derivation to this formula, but it's not required at this stage, or it doesn't come in the examination. So we'll just recall and use. Okay, so it is acceleration is equal to v square over r. You can substitute v by r omega, and this can become r omega square. So again, we have two formulas for acceleration. Moving on to centripetal force, we have been learning that centripetal force is equal to mv square over r. Substituting v square over r with a gives us ma, which is F is equal to ma, the resultant force. And then again, substituting a with r omega square. So we have three formulas for centripetal force. Since there are too many formulas, so it's easier to remember them if you write it down on a paper and place it in a prominent place in your room, so you can look at it whenever you walk by. It doesn't matter what paper you're doing, even if it's physics, chemistry, P2, P4, whatever. Just make a formula sheet for yourself so that it is easier to remember all these. Now let's look at a case. It's a stone tied to a string and whirling in a horizontal plane. So this is not a 3D diagram, so let me help you visualize a little. So this is a stone being whirled and it is obviously tied to a string. So it's tied to a string, and then just imagine that the weight of the stone is acting downwards in the y-axis, right? But the stone is tied to the string in the x-axis. So this is the x-axis. So the stone is moving in the x-axis, but its weight is acting in the y-axis. So just visualize it. So if I stop this movement at one point, I get this diagram, right? So let's look at by point to point. Let's look at point A. At point A, the weight of the stone is acting downwards, and as the stone is tied by a string, at this moment the string is at A, and since there is a string, so there must be a tension force which is directed towards the center. As you know, the centripetal force is directed towards the center, so tension must be providing Fc here. I am using Fc for centripetal force. Again, at B, the weight is acting in the downwards direction, but tension is present in the string. So tension provides the centripetal force. Same is the case with C and same is the case with D. So at all points, tension and centripetal force are the same, and only tension is providing centripetal force since it is the only force directed towards the center. So T is equal to Fc, which is T is equal to mv square over r. Let's move on to the last point of the topic today. It's the case 2, stone whirling in a vertical plane. So it's a stone, it's whirling in a vertical plane. It means that the y-axis, right? So let's see at point A. At point A, the weight of the body, the weight of the stone is acting downwards, right? But the tension in the string is acting towards the center. Since only tension is acting towards the center, so at A, only tension provides centripetal force. So T1 is equal to Fc. Let's look at B. At B, two forces are in the y-axis, right? So T3 is directed towards the center, but at the same time, the weight is opposing this tension. It means that the tension has to be greater than this weight in order to sustain the circular motion. If the weight gets greater than tension, it would break and the motion would be stopped. So we know that tension is greater than the weight. So we subtract the weight since it's opposite direction. It's in opposite direction, hence minus weight. So at B, centripetal force is provided by T3 minus W. At C, it's the same case as A. T4 provides the centripetal force. At D, it's the opposite of B, which means that weight and tension are both acting in the same direction, right? So it means that they both must be providing the centripetal force. So at D, T2 plus weight provides the centripetal force. There is an important point to note here that tension varies. As you have noticed that I have used the same symbol for centripetal force throughout, but I have used different symbols for tension, T1, T2, T3 and T4, right? So tension varies, but the centripetal force remains the same because acceleration is same throughout, right? So T1 and T4 are equal because the centripetal force is same. As you can see that weight is being subtracted from T3, so T3 must be a big number so that weight can be subtracted and it can still sustain the motion. And at D, T2 and weight both provide centripetal force, so T2 must be a smaller quantity. So we can write it as T3 is the largest, and then T1 is equal to T4, and then T2. So yeah, that's all for this topic, and good luck.